This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We're going to learn how to graph trig functions now. So here are a couple of examples of trig functions. Y equals 3 sine of x and y equals cosine of 2x. And notice the variables are x and y. The difference here is that we're going to think of the variables as being real numbers. So when I say sine of x, I'm taking like the sine of a real number. And we got that from the circular functions. So remember the circular functions here. So we have all of these, think of these radians, pi over 6, but really what this means is if you take a length, pi over 6, remember this is a unit circle, then the coordinates here, x, y, give you the actual cosine of that length. So the cosine of pi over 6 is square root of 3 over 2, and the sine of pi over 6 is 1/2. So let's just figure out what it is for the sine of these particular numbers here. So if I wanted the sine of x, in other words, I want the sine of 0, let's see, I go back up to here. 0 is right here, and you just look at the y value at 0. So the sine of 0 is 0. But I'm talking about the length 0. How about if we skip this pi over 6 and see what it is for pi over 4? So now I'm talking about this length from here to here, all the way up to pi over 4. I just look at the y value. It's square root of 2 over 2. And that is approximately 0.7. All right, how about if I keep going? I want the sine of this, the y value is 1, so the sine of pi over 2 is 1, etc. So you can go through and do all of those. Let's say you go over here to 3 pi over 4, the y value is square root of 2 over 2, again approximately 0.7. At pi, the y value is 0. 5 pi over 4, the y value is negative square roots of 2 over 2, so it's approximately negative 0.7. At 3 pi over 2 down here, we've got the y value. And when I say the y value, I mean the y coordinate of that ordered pair is negative 1. And at 7 pi over 4, we've got negative square roots of 2 over 2. It's approximately negative 0.7. And at 2 pi, we're at 0 again. So imagine you've gone all the way around. You know, this is a length of 2 pi. And I've got 0 again. Well, what if I want 9 pi over 4? That means I keep going. So imagine it's a longer string. If you want to think of it that number goes all the way up to here. I start repeating myself. I'm going to have that square root of 2 over 2 again, which is approximately 0.7. If I go up to, 2 pi plus pi over 2, which is, what is that, 9 pi over 2. Is that right? 5 pi over 2, sorry. Then I would have 1, and this starts repeating itself. So what's going to happen is if you try to graph this is the values you get are just going to repeat. So that's something to keep in mind when we're doing our graphing. So now let's go back and try graphing y equals sine of x using these approximations. And we could put a lot more ordered pairs in here. Like I could have done the sine of pi over 6, the sine of pi over 3, but I just didn't have enough room to write all those in here. But something to notice is what's going on with the y values. It starts at 0, right? The sine of 0 is 0, and it gets bigger until it gets to 1, right? See the y value is 1? That's the top. If you look at the height here, the top y coordinate is 1, and then it starts going down again to 0.7 to 0, and then it goes negative all the way down to negative 1. So I could put any number I want in for x. In fact, I could even put in negative numbers. I can go to the left, right, starting at 1, 0. And so I could put any number I want in for x. So there's no restrictions here. So the domain is going to be all real numbers. But notice that the range, the values y, they only go in between negative 1 and 1. If you look at the picture here, the y coordinates go in between negative 1 and 1. There's nothing smaller than negative 1, nothing bigger than positive 1. So let's try graphing the most basic trig function, and this shouldn't say 6, it should say sine of x. Graph y equals sine of x. So we noted that the domain could be all real numbers. There are no restrictions at all for what you could put in for x. But the range, in other words, the y values, only went in between -1 and 1. So therefore, notice on my y-axis, I just went ahead and put a mark for -1 and a mark for +1. And what's different here, instead of going 1, 2, 3, 4, 5, 6, 7, 8, since these are the values I chose for x, I went from 0 to 9 pi over 4, I'm going to do things in terms of pi. Now, I did pi over 4, pi over 2. If you want, you could put these all with the same common denominator, and you notice this could be thought of as, pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Some people find it easier to just write them all with a common denominator. So basically, it's hard to write all those little values here, so hopefully you could see this would be the pi over 4 right in between 0 and pi over 2. So let's graph these. I've got 0, 0. All right, so 0, 0 would be right here. All right, pi over 4 and about 0.7. So here it's about 0.7. It looks like it's about right here. Let's see, pi over 2 is up at 1. 3 pi over 4 is about 0.7 again. Pi, 0. 5 pi over 4, -0.7. So that looks like it's down about here. 3 pi over 2 is -1, about right here. 7 pi over 4 is -0.7. 2 pi is 0. And then 9 pi over 4 was up at 0.7. Remember we said that that's when it started repeating itself, so you can guess the next place over if I went up. It's going to be up here at 1 again. That's exactly what happens. Now, you don't know for sure what this looks like, but hopefully it sort of looks like a nice little curve that you could see. But you would need a lot more order pairs to tell for sure. But in fact, it is a nice smooth curve. It ends up being a nice smooth curve. So you could put in a lot more values, and that's exactly what a graphing calculator does. But what, for instance, would it be at negative pi over 4? Let's just look back at that unit circle again. Let's say you wanted to know what the sine of negative pi over 4. We already know that the sine is 0, 0. Now that just means I'm going down here, right? That's negative pi over 4. You're going in that direction, so we're talking about this length here, and the y value is negative square roots of 2 over 2. So that's about -0.7 approximately. If I went all the way to negative pi over 2, it's -1. So let's keep those in mind. If x was negative pi over 4 and negative pi over 2, we're going to get -0.7 and -1 respectively. So here at negative pi over 4, it's a -0.7, and at negative pi over 2, it is down here at -1. And if you put in enough ordered pairs, you're going to get this rough sketch here. And it is a curve, so you kind of have to get your pencil out and, sketch it as carefully as you can. Don't make it look like it has any sharp corners. It does not look like the absolute value function, for instance. Okay, and then it keeps going forever. So I put in little arrows at the end to get an idea. Okay. Now what happens is it started repeating after it went to pi over 2. So there was this in between here and here. This is a complete period. I'll explain what a period is in a minute. It starts repeating. after you've gone that far. Now there is no real beginning. I just happened to start at 0, 0, and that means when it ended at 0, 0 here. I could have started at pi over 2 and ended up here at 3 pi over 2. That would have been a period, or from negative pi over 2 to 3 pi over 2, etc. But there is one period is 2 pi. So the period of this function is 2 pi. That's like a space you could look on the x-axis and you could say after that much space it does start repeating. Alright, so what we've done is sketch the graph of y equals sine of x and just realize that this does go forever and ever to the left and right. The period of this function, which we'll define more carefully in another video, is 2 pi. And we want to pretty much commit this one to memory because it's the most basic trig function. Notice it starts at 0, 0, it goes up to 1, comes back down, is 0 again at pi, goes back down to negative 1, and then up through 2 pi, and then it just starts repeating itself. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.